Hi everyone. We're going to continue our empirical modeling today, and just as a reminder, empirical modeling is when you look at historical data or observations, see a trend in them, and you try to approximate that trend with some sort of function. So yesterday we did linear regression, in which case you approximate a trend that looks linear with a linear function, so a straight line. And we called it simple linear regression because we only had one independent variable or explanatory variable which we thought would somehow influence or predict or explain the response variable or dependent variable. So for instance, in one of the videos yesterday, we looked at the example of years of education as an explanatory variable that we thought would help predict someone's hourly wage, or the response or dependent variable there. So we had the single independent variable impacting the dependent variable. However, as the Aussie or Kiwi gentleman told you, I couldn't really tell which one he was, but the guy with the awesome accent, he said, this model isn't exact, right? There's some residuals or differences between the predicted hourly wage and the actual ones that we see for certain people. And that's because there are other factors that come into play for a person's hourly wage. And so he cited a few, one being experience. So the more experience you have in a job, presumably the more you're going to make per hour. Also, IQ works in a similar way. And then height does as well, and that's been shown statistically to be correlated with hourly wage. So there are all these other things that, in addition to education, may come into play when determining someone's salary or wage. So today we're going to actually bring in additional independent variables to try to increase the predictive power of our model. And so that brings us to multiple linear regression. So as I've already alluded to, the difference is, so we call it multiple because there's going to be more than one independent variable or explanatory variable that we think will explain the response or dependent variable. And then it's still called a linear regression, but I do want to point out that we can't really think about this anymore as a straight line, right? Because now we're working in some sort of space that's bigger than two-dimensional, so some n-dimensional space. And so instead of a straight line, we're going to be thinking about fitting some hyperplane to that data. So it's not a straight line, but it is, I guess, a straight or flat plane, depending on how you look at it, versus maybe some curved surface. So that's the idea behind multiple linear regression. So the example that we're looking at today is based on this cigarette data. So in front of me in this sheet I have 25 different brands of cigarettes, and for each one I recorded the amount of tar in milligrams per cigarette of that brand, the amount of nicotine in milligrams per cigarette, the weight in grams of each one, and then also the amount of carbon monoxide that's released measured in milligrams as well. And so what I would like to know is which of these possible explanatory variables best predict the dependent variable of carbon monoxide. So in order for me to run a multiple regression, so normally you would go to this data tab on Excel and look for the data analysis or simply the analysis piece. But I don't have that menu available to me, and if some of you are working in Excel 2010 on a Mac, that might be the case for you too. And so what I've done is I've downloaded a third-party add-on from the internet, and normally you should be a little wary of that, but I've vetted it and it's okay. It hasn't given my computer any viruses, and so the one that you want to look for if you have this problem is Stat Plus. So I'm going to pull it up right now. So you can't see, but in my applications toolbar at the bottom I've got this little series of, it's 3 dots and then 2 dots above it and then 1 dot above it, so that it looks kind of like a stair step. And it is just called Stat Plus. So if you Google Stat Plus like this, again, it's a free download, and it'll say for statistical analysis in Excel or something like that, and so you'll be good to go. For those of you that have the data analysis add-on in your data menu or data tab, then one of the other videos that I've linked to today explains how to run the multiple regression using that, so just be sure to watch that, which I think is a good idea anyway. It's kind of repetitive from what I'm going to tell you, but that's not necessarily a bad thing. Okay, so I click on Stat Plus in my applications bar, and it brings up my menus. I go to Statistics and Regression, Linear Regression, and first thing it asks for is the dependent variable. So I'm going to click on this box right here, and then highlight the CO data, and I highlight everything including the labels. Then I click back in the applications bar on the Stat Plus icon to pull this window back up. And so it has E1 through E26, which is in fact what I selected. And notice that I have this box checked for labels in first row, and that's because I did highlight the header row as well. If I didn't, I would just uncheck this, and then I would just be sure to be consistent with either selecting or not selecting the header row for the remaining information. For my independent variables, again, I click on this little box, and I'm going to highlight all 3 of my independent variables at once. Click back on the Stat Plus icon to pull the box back up. If you want to look at advanced options, let's do it. So I have the option to include a residual plot, which we haven't talked about yet, but it's mentioned in another video. Essentially the idea is if you plot the residuals and don't see an obvious pattern in them, then that's good. Your model is good. And if you do see some sort of pattern, then that's not so good. We're not going to look at that today, and we're also not going to look at line fit plots. This constant intercept being forced to be 0 is generally something you want to avoid unless you have a really good reason to click that. So we're not going to choose any of these options. We're just going to rely on the regression output for all of our information. So now I click on OK, and Stat Plus thinks for a minute and then gives me a new worksheet with the regression output. So let's see if I can make this a little bit bigger so it's easier to look at. Okay, so the most important things that you want to make note of on this output. First one is R² versus adjusted R². So we saw yesterday that R² value is the proportion of the variance in the dependent variable data that is accounted for or explained by the independent variable. So essentially it's how much, how well we can predict the dependent variable from the model. So in this case, we've got something like 91.9% of the variability in CO output is explained by tar, nicotine, and weight. However, we have this adjusted R² value, which doesn't come up in simple linear regression. But for multiple regression, this is really the value that I would say you want to pay attention to. And here's the idea behind it. So quite a bit of the theory in functional analysis tells you that the more variables that you have within your function, the more predictive it will be for sort of anything, even if those variables aren't directly related to what you're trying to predict. And the reasoning behind that is a little bit more involved than I really want to get into, but just sort of trust me on that one for now. So what I mean by that is, to this cigarette data, I could have also added a new independent variable, and that could have been something as bizarre as like the number of nickels that I had in my wallet when I bought each brand of cigarettes in order to collect this data. Okay, so if I added that as an independent variable in this regression, the total R² value would go up But we know that the number of nickels in my wallet has nothing to do with the amount of carbon monoxide released by these cigarettes. So even though the R² value goes up, the amount of nickels in my wallet shouldn't be predictive in any way. So that's where the adjusted R² comes into play, is the adjusted R² will only go up if the independent variable that you've added has significantly or meaningfully increased the predictive power of your function. So basically the takeaway is pay more attention to adjusted R² for multiple regression than for the regular R². So even the adjusted R² value is pretty high, so that's pretty good. Notice that this does give us the function that we would use in order to predict CO given any tar level, nicotine level, and weight for a brand of cigarettes. So that's nice that it writes it right out for us. Next thing to look at is the p-level of the overall regression. P-level is short for probability level, and if some of you have had statistics, then you're probably really familiar with p-level. If you haven't had statistics, the main thing to keep in mind is that a p-level that is small, and by small I mean something like 0.05 or less, a p-value that is small indicates that our model is significant. So that our model gives us predictive power because there's actually a relationship between the independent variables and the dependent variable, rather than just being due to random chance. So once again, small p-level, 0.05 or smaller, means that there is a strong association between your explanatory variables and the response variable. So our p-level here is way smaller than 0.05. Notice that it's times 10 to the minus 11th, so that's super, super tiny. So that's good for us. So now we want to look at the p-values or p-levels of all of the different variables. And so we have a p-level for the intercept, and that's kind of important to look at, but more important are the p-levels for the three independent variables that we included today, tar, nicotine, and weight. And so again, you want these to be 0.05 or smaller in order for them to significantly influence the dependent variable. And so for tar, we have something smaller than 0.05, which is why Excel tells us that yes, it is significant, so that's good to note. But the other two, nicotine and weight, the p-levels are much bigger than 0.05, and Excel is telling you that both of these are not significant. So what that indicates is that tar is the most influential of the three variables on CO output. However, it could be the case that if we run this multiple regression again with only two independent variables, so for instance with just tar and nicotine or just tar and weight together, we want to include tar in there because we know that it's significant. But if we drop one of nicotine or weight, so let's say that we throw weight out and just do tar and nicotine, it could be the case that when we just have those two independent variables, nicotine suddenly becomes significant. And I don't want you to worry too much about why that's the case, although basically the short of it is that nicotine and weight could be so closely related that their significance is sort of split across the two. And so, you know, if those two variables are confounded, then removing one of them will make the other one show up stronger. And again, if that doesn't make sense, don't worry too much about it. But so that's why once we've run the full multiple regression, we want to go ahead and run smaller multiple regressions until we get down to just simple regressions. So your next steps from here, and I won't show you this just because it's going to be tedious and more of the same thing, but your next steps would be to look at just tar and nicotine together, just tar and weight together. Don't worry about nicotine and weight together because neither of them were significant with tar included, and so you want to include everything that's significant as you go down. And so then you might just run a simple regression with tar and CO, and then compare that R-squared value to all of the adjusted R-squared values of your multiple regressions and pick your best model based on that information. So that's pretty much it for using multiple regression on Excel. Remember that if you do have the built-in data analysis, you can see on the other video, the one that uses Excel, how to run the multiple regression using that. Otherwise, you're pretty much set to do your exercises. So again, I'd encourage you to watch both of those other videos just because they remind you of some of this information, a lot of which is new. And then let me know what questions you have. Thanks.